So today I'm going to return to the TRS-80 Model 1 and the disk drives. I'm going to dig into the drives and see what's going on inside them. Also planning to dig inside the expansion interface and see what's going on there. Hopefully we'll be able to solve the mystery of that enhanced floppy drive controller board that's not installed in the system but has apparently had the controller chip harvested from it. I'm not sure what the deal is with that. Hopefully we'll be able to solve a bunch of mysteries today, but you know, you never can tell with old computers. That's part of the adventure. And hopefully I'll be able to play some more games, but we'll see. It's probably because there's gonna be a lot of dissection going on. It'll probably stretch out to a fairly long video, so we'll see how far I actually get. Now, today is also kind of a big day for me, for two reasons, actually. One, today is the 1 year anniversary of the channel. I had set a goal when I started the channel of averaging one video per month. So I really wanted to do, in the first year, I wanted to do 12 videos. Technically, I will have accomplished that goal, although it has required in the last 5 weeks doing 5 videos. So, I mean, I made the letter of the goal, even if I didn't really follow the spirit of the goal. But you know what? I'll take the win. Today, I also noticed I hit 400 subscribers. So that's pretty cool too, considering that before Septandy, I think I had like 22 subscribers. So the last month has been pretty big for me. Getting the shout out from Geek with Social Skills and the shout out from Adrian's Digital Basement definitely helped boost my subscribers and my views. But I'm just going to keep trying to make good content and just keep the ball rolling. So let's go ahead and dig into those drives. All right, let's dig into these drives. Now, I've had a little bit of a closer look at this drive, and I have a new hypothesis, but we'll see if it pans out. So my original hypothesis was that this drive had originally been in this case, and that it was replaced as either because it stopped working or because the drive that's in here now was some kind of an upgrade, possibly related to the enhanced disk controller that I showed in my previous video. Now, a few people mentioned to me that it doesn't require a different disk drive to get high density, or increased capacity. I guess it isn't really high density, but increased capacity on these systems. You just need the controller and an appropriate version of DOS to be able to handle it. Okay, so my new hypothesis is this drive has the terminating resistors hard mounted, and this block here has all of the connections blown out of it except DS0. So my new hypothesis is that when the person added these extra drives, that you can't have two drives configured for DS0, and this one was kind of stuck, and presumably this other one is also stuck as DS0, so had to replace one of the drives in order to be able to have 3 separate drives. That's my working hypothesis. So I'm gonna start by opening up this other drive. It should be identical to this, and that will probably partially confirm or perhaps refute the hypothesis, and then I can move on to this one. So I'm going to set this guy back over here, kind of out of the way, but you can still live in the frame a little bit. And let's go ahead and open this one up and see what's inside. Okay. let's have a look at this. Okay, so the terminating resistors are still definitely hardwired in, but this is different. Okay, what does that mean? So none of these pins are separated in this block, so I don't know what position that would configure this drive for. For whatever reason, in this part, I was really hung up on the idea that the drive ID was selected by the drive ID jumpers on the drive itself. I had read in at least a dozen different places that the drive ID is specified by the position on the cable, but it didn't sink in properly. On PCs, there's a twist in the cable, so it's obvious that the two drive positions are different. On Amigas, if you look inside the pass-through drive cable port on external floppy drives, you can see that the drive select line that's actually wired gets shifted down by one. All of the external drives are configured for one specific ID, but because the wires that go to it are shifted by one, each drive ID gets shifted by one as it goes down the daisy chain. Okay, that I can see, and it registers in my brain, aha, these things are different. The position determines the ID. But for whatever reason, it didn't, I couldn't grok it on the Tandy drives. Because it's not the cable that determines the drive ID, it's the connectors. Inside each connector, there's positions for the 4 drive select lines, and on each connector, 3 of those are non-conductive. Only one of them is actually going to connect the wire to the drive. So because the connector is different and the connector specifies the drive ID, each drive gets a different ID. But you have to really look inside those connectors to be able to see, aha, they're different, and then, yeah. So in this whole section where I'm trying to figure out what the drive ID jumpers are set to, just ignore all of that. You don't need to roast me in the comments. I've already roasted myself plenty when I realized, oh, come on, read and think. All right, so now I'm going to return you to your previously scheduled rambling about floppy drives. This MUX pin is lifted. I don't know. Okay. And this chip socket is empty. Okay, so that's unusual because that socket is populated on this drive. I'm going to zoom in. So that socket is populated on this drive, but it's weird because the chip that's here doesn't fill out the socket. There's 2 empty pins at this end. And it looks like maybe it's in backwards, because here's the little dimple that usually signifies where pin 1 is. But then here's the mark on the chip that says what its pin 1 is. So, okay then. Well, have not solved the first mystery, but have added at least 1 or 2 more to the list of questions. All right. Well, I will set that off to the side there, and let's take a look at this one. Now, this, I think, is the same enclosure, and that this drive was originally in it. So, hopefully, hopefully whatever is in here will solve at least some of the mysteries, or yeah. Okay then. So this looks pretty much like the identical drive board. I mean, there's a couple of small differences, like in the layout of some resistors here and there, but this is the identical drive board. They're even the same assembly number. Okay, so they've got the same hard-mounted resistor packs. This is set up exactly the same on both, and this chip is unpopulated on both. So when these were, all right, maybe I was incorrect in assuming that these were the drives. I mean, they have to be the drives that were connected to that computer. There was no... What the heck is going on? Okay. Let's set them both to one side. And, of course, the one that's different has to be different and has to use flathead screws. Fortunately, I have appropriate driver handy. Both of those other drives were Aerocomp enclosures, and two of them were Aerocomp branded drives, although this is just a sticker that they presumably put on someone else's mechanism. This drive has different branding, and is a completely different sort of enclosure. And it is branded by Sirius Systems, and it says SS8. I'm assuming that's of 2, or maybe 80T2 BB0018. They're from Knoxville, Tennessee. And on the back, 80 plus disk drive, Sirius Systems, Knoxville, Tennessee, and a power switch and the connector. All right, so nothing too exciting there. Now that is quite a bit beefier of a power supply than in those other drives. All right. And it's the same, the exact same mechanism. Except this drive has the chip installed, and it's in the same seemingly backwards orientation as the one other drive that had something populated in here. And this does not have the mux pin lifted. What almost looks like that's maybe broken there. Difficult to say. Well, what the deuce? Oh no, so that's interesting. So on this drive, the cable, the connection comes in to this little board, and there's some stuff wired up and configured on this. So, only certain of these pins are connected here. So I wonder if this is, I would have to definitely go and look up which pins on the floppy cable mean are the drive ID, but I'll guess that this somehow configures the ID. And there is another interesting tidbit in here. Checked July 15th, 1980. So, since this is different from the other two drives in some fairly substantial ways, I'm going to guess that this is drive 0. Because drive 0 should be different. The whole thing about there are several things about this. So this is kind of sketchy. So because this board is mounted here and this whole thing moves, there's a little piece of electrical tape over the bottom of this circuit board, and then another little piece on this aluminum backing. Now, I would do stuff like this for my own personal use, but I don't know that I would ship a product like that. I guess the 80s were a different time. Just ask Rick James, I guess. All right, let's go ahead and just hook this up. I'm gonna have to go find my DOS discs. I know I have them somewhere. I have several different versions of DOS that I've acquired over the years for Tandy's. So I will go try to find one. I will hook this up in position 0. I think I'll start with these drives not connected at all, and I will just go from there. Okay, everything is all hooked up and plugged in and connected. I haven't turned anything on yet. Hopefully this will work. So off camera, I did check the power supply on the drive. The voltages seem okay. The 5-volt rail was a little bit low. I would honestly prefer to not use the power supply in this, but the power supply, the way it's connected, it also powers this chip and the stuff on this board. So I didn't want to not use it badly enough to desolder and reconfigure power for that. So I'm going to give it a go like this. If it doesn't work, I'll see if it's power supply related. And it looks like I don't have the expansion face plugged in. That would cause things to not work. All right. Well, let's go ahead and do this. Turn on this part. Turn on that. Cue the high pitch monitor noise that I can't hear. Reach over and turn on the disk drive. And turn on the computer. Okay, so the disk spins and then stops, which is interesting. So, all right, well, that's something. I have 2 copies of TRS-DOS that say they're for Model 3. I looked in the manual that I have for one of them, and it says that I believe that it will actually work with a Model 1. I don't really know of a strong reason why it wouldn't. So I've never used either of these discs. So I'm going to give this a go. All right, so now with the disc in. All right, so I would have thought that it would just keep seeking, or keep trying. Let's turn off. So this must not be the one that is number 0 then. Okay. Well, I guess that's one way to solve the mystery. Well, that seems, I don't know, maybe not. All right, I'm going to try each of the rest of these drives in turn as number 0 and see if I can get anything to work here. Okay, so this drive, the AeroComp branded drive, performed exactly the same. This drive is different. So when I turn the drive on, it instantly starts spinning. So that's some kind of additional sign of life. And then if I turn on the computer, it clicks like once when the computer first comes on. And then I let it spin and spin and spin and go basically forever. And that's it. It's the head is not moving. It's not giving any signs that it's actually reading from the disk. I guess I can check. It's possible the head just could be like seized up and not wanting to move. All right. Let me try a couple other things before giving up. This may be close to give up time. All right, so I wanted to check to see if the head moves. Sometimes they get seized up. So it does, you can manually move it. It's a bit rough. I think it's okay. And then when turning the computer on, order of operations, turn on the drive, turn on the computer, does eventually make its way back. That I'm a little bit suspect of. I don't know if that means it just needs lubrication or what. Let's try putting the disc in and see. Yeah, and it just spins and no sign of anything. I guess I can. And after I turn the computer on, the drive does make a little bit different sounds. But maybe that's just wishful thinking. So I don't know. I would definitely love to hear any thoughts or suggestions. I suppose it's possible it was that not connected all the way. Wouldn't that be silly? Okay, so it wasn't that. I would love to hear any thoughts or suggestions about what might get this working. I feel like these drives should work, and I'm just not doing it right because everything else with this system has worked, so I don't know. But in the meantime, we can still go ahead and take a look inside this expansion interface and see what's going on in there. All right, so it's time to take a look inside of this. But before I start ripping this apart, I did try a couple other things with the disk drives off camera. I have another expansion interface, so I tried using that to see if that made any difference, and it did not. I also tried this bare drive, just directly connecting the cable to the drive itself, and then using an external power supply that I have that has a little Molex connector on it to see if that drive worked, and it did not. The head would move and it would do some of that stuff, but the motor did not spin at all. So maybe one mystery is solved, and that drive actually is deceased, and that's why it got swapped out and then just kept for spare parts. I don't know. But anyway, we can move on and take a look at this and try to at least have something interesting happen here. So on the expansion interface, there's these doors on the top which are the power supplies, are supposed to be inside there, but on this one they're not. They're kept external, which the more I've used this, the more I like, because these get hot, and I don't think I want two red hot bricks inside here. That doesn't seem like a great design. And then underneath this one is a space where other devices can be connected. So I'm gonna go ahead and disassemble those. On the bottom, I believe, are the screws. I'm just trying to look through the grills here and see what's going on. I believe that these are the screws that actually hold the thing together, but we'll do a full disassembly. All right, let's have a look under here. And there's nothing. That's interesting. For installation of the RS-232, this unit must be returned to the repair center for addition of connector. That is super lame. There's supposed to be a connector in here where the RS-232 board goes. That's really lame. All right, I'll have to open up at least this compartment on the other expansion interface to see if it is similarly under-equipped. Okay, and inside here is where... Now, I wonder if this duct tape is standard Tandy issue. But in here is where the two giant power bricks would go. One of them connects internally, and then the other one, the cables snake out the back. And now the moment that at least I've been waiting for. So, what the heck? So, the added RAM. And then this is a board similar to that other floppy drive enhancer, but different. Well, that's interesting. And then this must be the relay for the second cassette port. LN Doubler by LNW Research Corporation, 1981. And this does have both floppy controller chips in it. Huh, interesting. There's a few little bits of cobweb in here. And then I wonder, so this is still mounted with a couple of screws. Let's go ahead and take this out and see if there's anything on the other side. Okay, so that pokes through a little bit. Okay, what are we stuck on? All right, and there is the whole board in all of its glory. Ugh. That is Bodge-tacular. Oh my gosh. Is that standard issue? What is going on there? That is crazy. It's... Wow. That... I have never seen anything like that on any computer board ever. That is ridiculous. It's just a... So each one of these lines, which those must be the RAM chips on the other side, and then probably, so they're like terminating resistors? No? I don't. So it's almost certainly going to ground. And there's a similar configuration here that there was just a more convenient place to put them all. Wow. This is great. So I wonder about the rest of these bodges, if those are standard issue as well. That is ridiculous. All right, well, there it is. Again, in all of its glory. Let's see if I can put this back in without breaking any old plastic. So the big question mark is, why do those floppies not work? Am I just doing it wrong? Are the drives not good? Is it maybe somehow related to this expansion board? I mean, I guess it seems unlikely that any of those crazy bodges are related to this. So it seems like I could just pop this board out and pop the original floppy controller chip out of this board and put it back in that board and try to get it to work. It's also possible that my TRS-DOS disk is bad, or that version of TRS-DOS, for whatever reason, legitimately doesn't work with either the Model 1 or the Model 1 with this thing going on. There are a lot of variables, and that poses some problems. Well, that version of TRS-DOS at least claims to be for the Model 3. I know someone who has a Model 3, so I could at least go get the disk tested and be sure that the disk actually works. So that would be something. But unless anyone has any brilliant ideas, I am really not sure what else to try. This is the other expansion interface. I've already taken the screws out. So this is what the interface connector for the RS-232 interface is supposed to look like. Not, let's see if I can do this without the board falling out. Not that. Not that just hole where the thing should be. So that's lame. I'm really bummed about that. All right, well, that was a little bit of a bummer. I was really hoping to end this with working floppy drives and being able to load disks and do all kinds of fun stuff, but it wasn't to be. I've done some additional research since filming the rest of it, and I am quite sure that this is the primary drive. That mystery chip that seems to have been installed backwards, I am almost 100% certain is the terminating resistor pack. I've found the instruction manual for these models of drives. The other reason that I'm pretty sure this is the primary drive is the three other drives are Model 51. They are single-sided, double-density drives. But this is Model 52, which is a double-density, double-sided drive. So it seems logical that the most capable drive would have been the primary drive. I think that also solves the mystery about the two floppy expansion boards. That probably the person bought the first one and these AeroComp drives, and then later on upgraded to the double-sided drive, but needed a better floppy controller to be able to control the double-sided drive. I found some other documentation about that floppy controller, and apparently it's one of the few, maybe the only floppy controller, they call them doublers, for the Model 1 that can that can operate an 8-inch drive. Now I have an 8-inch drive that I've never used with anything. So maybe someday if I can get 5¼ inch drives working with that thing, I'll see if I can wire up a way to actually get that. I can't even say it with a straight face. It's so ridiculous. If I can get that 8-inch drive wired up, I don't know what good that would be. I mean, maybe then you could read Model 2 discs. Like, I don't. It's a thing that you do because you can. Other than that, I don't think there's any reason to do it now or then. It definitely qualifies as weird stuff, so we'll call it legit. I think this is probably going to do it for Septandy videos. I might do one more little short one because I found another piece of stuff that I have that needs a little bit of repair, so I might do a short video about that. In October, I'm going to transition to doing Unixtober. So I'm going to dig out those Sun workstations, and I probably have a couple other things that I'll try to get to. And just, yeah, have fun with some old Unix stuff. So until then, try to remember the good stuff.